All right, so let's take a look at number 10. Write in component form a vector with magnitude of 12 and direction of 240 degrees. Well, we have a formula for this, don't we? So in component form, we want the magnitude times the cosine of the direction. And then we want the magnitude times the sine of the direction. And so now it's just a matter of us evaluating those trig functions. And so we've got 12 times blank, comma 12 times blank. So 240 degrees is in the third quadrant, and it is 60 degrees away from the x-axis. So this is essentially a 60-degree angle. Again, in the third quadrant, cosine would be negative and sine would be negative, right? All students take calculus. And then we're just thinking about our 1, 2, 3, 3, 2, 1 chart. The cosine of 60 degrees is 1/2, and the sine of a 60-degree angle is radical 3 over 2. And so we've got -6 for our horizontal component and -6 radical 3 for our vertical component. And there it is. All right, number 11 says find a unit vector. Remember, unit vector means a vector whose length is 1 or whose magnitude is 1. And we want it to go in the same direction as -2i plus 5j. I'm just going to get a quick drawing here. So we're going to go back 2 and up 5. So here's vector right here. Here's our vector. I want to find a vector in the same direction, so along this same angle, but whose length is only 1. So we just want to scale it back. We just need to figure out how much to scale it back. So let's find the length of the vector they gave us. So we've got the square root of blank squared plus blank squared, right? 2 squared plus 5 squared. We're using the Pythagorean theorem. 4, so the square root of 29. And so if this vector has a length of radical 29, I want to divide it by radical 29 to get our new vector. So I've got 1 over radical 29 times, I'm changing the form and I don't know why, the vector -2, 5. So I've got -2 over radical 29 and 5 over radical 29. And whether we use i's and j's to write that or we keep it in this component form, it's the same thing, right? So we just found the length of our vector and then we scaled it back so that the length was 1. All right, so number 12 is asking us to calculate the dot product of the vectors and then find the angle between each pair of vectors. And we'll need a calculator, and let's make sure that calculator is in degrees. And I already checked mine. All right, so, I'm asking us to do 2 things here, and the good news is the dot product is part of our formula to find the angle between 2 vectors. Remember, the cosine of the angle is equal to the dot product of 2 vectors divided by the product of their magnitudes. I need to refocus this, looking a little blurry. That's much better. Okay, so let's start with the dot product, u times v. So -5 times 2 is -10. 3 times 7 is 21. And -10 plus 21 is 11. So there's our dot product. And now we can put that in our numerator, right? So I have the cosine of the angle equals 11 over, and then I need to find the magnitudes of both vectors. And we already talked about magnitude. We take a squared plus b squared. So 5 squared is 25. 3 squared is 9. 2 squared is 4. 7 squared is 49. I didn't really mean to squeeze those in there like that, but... All right, so we want to get theta by itself, so we're going to do the inverse cosine of 11 over radical 34 times radical 53. I'm going to go grab my calculator. So I've got my in degree mode. I guess I can stick this in here. I've got the inverse cosine of, and we've got 11 on top, and we've got the square root of, what did I just say, 34? Get out of that square root, times the square root of 53. And we get 74.982 degrees. And it wouldn't hurt us to draw this, sketch it, you know, just to get an idea. Is the angle supposed to be obtuse? It's supposed to be acute. So we certainly could take a look at that. I don't have any grid paper with me, but that would be a great option, is to just get a quick sketch. Let's see if I'm going to be going back 5 and up 3. There's one vector. Or I'm going over 2 and up 7. There's the other one. Again, very, you know, estimated. But yeah, I mean, that's about my 74-degree angle. Okay. Awesome. Let's do the same thing with part B. There's my two vectors, just in a different form, and if it makes you feel better to write 5, negative 2.4, and then our other vector is negative 2, 0. I mean, just to get the clutter out of there. So the first thing we want is the dot product. We want u times v. And so I've got 5 times negative 2, which is negative 10, plus negative 2.4 times 0. So my dot product is negative 10. And now I can start finding the angle. So the cosine of the angle equals, I've got negative 10 on top, and then I'm going to multiply the magnitudes on the bottom. So I've got 5 squared plus 2.4 squared, I'll let the calculator do that work, times, and then I've got 2 squared plus 0 squared. I guess I didn't need a square root to find that magnitude. That's okay. All right, so I've got my inverse cosine. I went ahead and move that over. So I have my negative 10 on top. And on the bottom, I have the square root of 25 plus 2.4 squared times my square root of 4. I don't know why I just didn't call that 2. And so we have theta equals 154.359 degrees. And again, I mean, just a quick little sketch just to make sure we're in the ballpark. So let's see, we're going here, we're going over 5 and down like almost half of that. And then here, we're going back 2 and up 0. So the angle between them, yeah, I mean, yeah, looking, you know, there's 180. So I'd say that's a really good check. All right, let's take a look at number 13. It says vectors u and v are orthogonal. Remember, orthogonal means perpendicular, and we've now also said that means their dot product is equal to 0. Find all values for b. Well, here we go. We know exactly how to get started. The dot product is 0, so 2 times 4 is 8, plus, and then I've got 1 plus b times 1 minus b, and when I add those together, we know we should get 0. All right, well, let's multiply this out. That's a difference of squares, so I have a 1 minus b squared. So I have 9 minus b squared equals 0, or b equals plus or minus 3. Right, b squared equals 9. All right. And again, we could do a quick little check. What happens if b is 3? If b is 3, I have the vector 2, 4, and 4, negative 2. We could do a quick little drawing there, going over 2, up 4, or going over 4, down 2. I mean, we have, it's not perfect. If b is negative 3, we'd have the vector 2, comma, negative 2, and 4, comma, 4. And we could draw that one. Over 2, down 2, over 4, up 4. Yeah, again, not perfect. I'm just kind of getting visually if we're in the ballpark, if both of those will work. Great. All right, let's take a look at number 14. We have 3 force vectors, F1, F2, and F3, acting on a point P. Find the resultant force vector, and we know with vectors the word resultant means sum, its magnitude, and its direction. So we want to add all 3 of these things together, and we know adding vectors is as easy as adding the horizontal. I'm going to call this F sub S for the sum. We're going to add the horizontal components to get a negative 9. Let me double check that. Negative 14 plus 5. And then we're going to add those vertical components to give me a negative 4. So there's the resultant force vector. And now we need to find its magnitude and its direction. So the magnitude of the resultant is the square root of 9 squared plus 4 squared. And they said use a calculator at this point. I mean, I could grab one. I'm not hung up on it. Let's see, and that gives me 97. I didn't need a calculator to get that. Certainly we could turn that into a decimal. And the square root of 97 is 9.849. I didn't, I think the exact value is always better, but either way. So there's the magnitude of our answer. And now we want to find its direction. I'm going to draw it. Negative 9, negative 4 goes back 9, down 4. So here's our answer. We just found the length of it. And we're starting to talk about the direction. Remember, direction is the angle from the positive x-axis. We either sweep down or we sweep up and over. Right? There's that direction I'm looking for. The easiest thing to do is to find this little guy right in here. Let's use tangent. We'll say the tangent of x equals 4 over 9. Not negative 4, not negative 9. I'm just looking at that right triangle. So I'm going to do the inverse tangent of 4/9, and I get 23.962. Again, I did the inverse tangent of 4 over 9. So my itty bitty angle in here is that 23-degree angle. But if the direction is 23, that'd be way over here. We're going to add 180, right? Here's 180 degrees to get us the other side. And then we know we need to add that 23 more. So my direction, so when I add 180, I get 203.962. So my direction is 203.962 degrees.